Okay, so back at it. My camera's shaking here a little bit. We got it very precariously set up. Okay, so let's move this model out of the way for a second. Our fabric of space. So, we know that in a black hole, all the matter of the universe, or all the matter in that general area of space, is being sucked into the hole by the extreme gravitational force that is exerted in that area. So we have the hole, and then we have the event horizon, the accretion disk. So the accretion disk would consist of all of the stars, the surrounding matter, all of the planets, all of the mass that's in the area that's being sucked into the hole like the drain in your sink. It's being spun around and around and around. It's being sucked down the hole by the gravitational force, the density of the material that's in the bottom of the hole. What else do we know? We also know that there are jets that extend from the black hole. A type of exhaust when the black hole begins to gorge on cosmic matter, on stars, planets, everything in the neighborhood. When it begins to gorge, we know that oftentimes it spews matter back out from the hole. Now, how would the matter at the bottom of the hole become super dense? Well, it's being relieved of all of its space. It's being condensed. All of the space in between the electrons is being voided. It's being negated, and the electrons are being ejected from the hole. So, in a universal sense, in a big crunch sense, what we'll end up with is a type of action potential, much like the nerves in a body, in a human body. We're going to end up with potentially the neutrons and the protons inside of the hole in a super dense material. And of course the space in between all of that matter no longer exists, and all of the electrons exist outside of the hole. And I don't know if you can see that because it's black material, and I hope this doesn't shoot like a slingshot. So what we then have is an area of extreme mass, density, bending the fabric of space. Outside of that hole are the electrons in the space that once existed between all of this material. So therefore we have an action potential. We have negative electrons outside the hole. We have neutrons and protons inside of the black hole. So potentially, what could happen in a Big Bang situation could be that, much like a magnet or an action potential in a nerve, when it reaches a trigger point, all of the material inside of the hole could potentially be forced or sucked out of the hole by the electrons that are outside of the hole, creating what might be a very static platform. So the fabric of space may indeed become negatively charged. Causing all of the material in the hole to eject. And then, boom, spread out. Seeking electrons, seeking the octet resolution. So that would be a lot of reactions occurring at once. So at this point in the Big Bang, the material is out. It's no longer a homogeneous mass. It's begun to seek the electrons. The electrons are dragging it in, dragging portions of it in. Reactions are happening all over the place. So let's move forward a few moments in time. Almost like what we have now. Now I say a few moments in time, I mean some period of time after the Big Bang, because we know that time is a construct. We have created that for ourselves. And we know that none of that exists in a black hole. So we've pretty much created that for our own comfort, I guess, for our own sense of order. It's necessary to have that. We needed that. Anyway, moving right along. So, let's move to today. What we have is our galaxy and the many other galaxies that exist in the universe. They all have a particular place on the fabric of space-time. Now, back to the black hole. This is where the rest of the theory comes in. I imagine, I suppose to you, let's imagine that the matter has not been forced out of the hole by a rebound of space fabric, of space-time. Let me see if I can shoot this and catch it again. It hasn't been ejected by the fabric of space, but it's been sucked out by the electron field, by the action potential, which is a medical term. It's probably used in batteries too. The action potential of the nerve. So the action potential that exists in the fabric by the presence of the electrons. If the mass has been sucked out, the depression or the gravity field may still be present. But not to such an extent, because perhaps that divot in space is beginning to rebound back to its original shape before the mass was present. But if the mass were sucked out of the hole by an electromagnetic force, and the divot still was present, then as space began to rebound, you might see that space is actually getting bigger. Because no longer is the material, the fabric of space, crunched down inside of the black hole. It has begun to rebound and come out, albeit not as fast as the material had been sucked out of the hole. So now back to the weak force of gravity. Well, if this material is rebounding and space is going back to its original shape or to a flatter surface, its original shape before the material were present, then why isn't it taking all the stars with it? Why isn't it just breaking all those galaxies apart? Well, because the weakness of gravity, the weakness of the gravitational force, the electromagnetic force that holds all of the planets together like a molecule is stronger than the weak gravitational force that's exerted by the rebound of space fabric. So rather than ripping galaxies apart, it's simply moving them to a different place as a whole, making them appear as though they're moving further away. And perhaps they are, because if you give it more material up from the bottom of the pit, it is going to stretch out and move this way. It's going to spring that way. So that's my theory. And the black matter, or the dark matter, may actually be the fabric of space-time itself. In the electron mat, the electromagnetic field, the background that you see on your television set, the background electrons that are, they say they're left over from the Big Bang, that we see on our cathode ray TVs and our, well, actually you see white noise on flat screens as well. So, but yes, so are they left over? Yeah. To put it in a phrase, they could be left over, but the force that pulls things, that seems to be dragging space material, the galaxies along, away, may very well be the fabric of space itself, unfolding. Now, just as space-time can have a divot downward, it may also be capable of taking many different shapes. Perhaps a peak. Now what is that? I'm forgetting the word. A parabola? Almost like a tunnel? This shape? Without the tunnel inside, but theoretically like a mountain in space fabric. Now that might be, so in which case you might also see the material of space come up from what used to be a black hole, but then spring and just keep moving. Almost like you would see a wave on the water. Now they want to see if they can see gravitational waves in space. And they're setting up all experiments to see if they can see that. Well, if that is true, then just like water, only probably a lot easier than water, but we can visualize it as water, but maybe even with less effort, space might reverberate from all of the activity that's occurring on it. And of course, it's doing this in our time, in what we call time. How fast that's actually happening and what is real time, well, that's a completely different subject. But, so if you had a shape like this, that might be where your wormhole travel comes in. Where you could, rather than go up and over the mountain, you could go through the tunnel. How would that happen? Well, I don't know that you would put a rip in space and time. It would be like saying, I'm going to drive my submarine through the ocean and I will tear the fabric of the ocean. Is that what you're doing? No. You're sort of just moving through it, and it might be a way to do that. But I haven't thought of that yet, how that could occur. But so anyway, that's what I'm thinking. That might very well be why space is expanding. And we see it as expanding. The weak force of gravity is allowing the clusters of galaxies to stay on the fabric of space right where they are, give or take, and ride right along with the fabric. So as the it's not going to work. It's not going to cooperate now. I'll use the paper. As our clusters and galaxies get pulled out of the hole and move along, they go right with it. What do you think?